Hi everyone, it's Alex with Wide Awake Travels. This video is going to be about the bed lift that we made for our Skoolie. We decided to make a bed lift because we bought a 30-foot bus and we are a family of four and we have remote jobs, so we need office space, we need storage space, and we had to get creative with our space to save it. So we decided to, in our bedroom, our bed, which is a queen size bed, to make a mechanism to raise it above, so during the day we can have a desk, access to storage, or a washing machine maybe, and then at night we can lower it and we can sleep on the bed. Some people make these bed lifts out of winches and some other mechanisms, but I wanted to do something different, so I decided to use 4-track actuators, 12-volt track actuators in 4 corners of the bed, built into the walls, into the frame of the walls, so they can be kind of hidden, connecting to the bed frame, all working together through one switch and relay to go up and down. There is already a product you can buy called Happy Jack bed lift, but that is over $2,000 last time I checked. That's a kit that comes in. It's much easier to install than what I'm doing, but with my method, we saved a lot of money that way. All 4-track actuators cost us about, and the brackets cost us about $1,000, and then you need a relay and switch, and that's not a lot. So basically around $1,000 or so for the bed lift, versus over $2,000 for the Happy Jack. Sometimes you can find a good deal for Happy Jacks on the internet, or like Facebook Marketplace or places like that, but it's kind of rare. Maybe you can go to RV salvage yards and find them there. Anyway, this video, it will show you. Here's the bed lift. You can see 2 of the track actuators. This video will show you how we've done it. I got a track actuator over here that is somewhat similar to a linear actuator, except the length of it is fixed. So with a linear actuator, the rod comes out and the length is getting, longer and longer. With a track actuator, the length is fixed, and the part that moves, it just moves up and down that length. This is what's going to be used for the bed lift mechanism. We have 4 of these track actuators that we're going to basically put kind of in 4 corners of the room, and the frame of the bed will be mounted to them over here, and they're all going to be controlled through 1 relay and 1 switch, and that will rise them up and down at the same time. And when I built the framing, I built it so the framing is all at the same height from the ground, which should be about 30 inches here. And I just have to come in here and install them. Here I have this one of the track actuators, and I actually replaced the mounting bracket. This bracket is going to connect to the bed frame, and the one it came with was just too small. It wasn't sticking out enough, because I needed to stick out enough because I'm going to hide the track actuator in the walls, in the framing, and I needed this to stick out more so it can pass the walls and the outlets and everything. So I just bought some L brackets on Amazon, and I drilled the holes for the screws. I have to add another screw here, so that way it's sticking out now more. Instead of being like this, it's sticking out more. So I'm doing that for all the track actuators. So I'm taking this pin here so I can get this off. Because I gotta install this. Come over here. I've marked, when I mocked it up, I marked 2 lines on the side so I know where it needs to go. Alright, that's solid there.
Alright, now I'm gonna come over here, put it on. I gotta get the pin in. There we go. And then this pin now. I bend this pin too, so it can't come off. This is how a mounting bracket at the bottom looks like. Here is I temporarily put this up so it doesn't fall. So here are the jack studs that I made. This part of the framing where the track actuators sit. These studs go all the way down to the floor. So that transfers all the weight instead of relying on some screws holding all the weight. It's just the stud is gonna hold the weight. So this will never break or fail. I put the frame here where it's gonna go. But before that, I added a layer of 1/2-inch plywood and a layer of cedar tongue and groove, because that's gonna be on under it there, like to serve as a ceiling when the bed is lifted. So I needed to put that on to make sure when I mount it to the track actuators, it stops at the right height. And then I got these 1/4-inch thick brackets on Amazon, and I have 2 brackets on each track actuator. So they're gonna go like something like this, and another one on this other side right here. 2 on each one, so 8 total. And they're gonna be holding the frame, the bed frame. I have to cut them and drill holes and all that, but that's basically it. It's looking good, it's sturdy. It's not flexing or anything. Okay, you see this stud here that goes all the way to the bottom, to the floor? This is just temporary, but I will put something like that, just prettier, permanently. That way the bed frame rests on the studs. I'm gonna put them in 4 corners. Well, actually this one, on 2 of them, is gonna sit on top of this storage box, dresser and all that. But then the other 2, that over there and right here, that's gonna sit on these studs that go all the way to the floor. That way the weight is not being held by the track actuators, it's held by, you know, solid support underneath. My goal now is to get this track actuator to sit straight up. Measure the distance from this stud to here, and measure the distance from the back of this stud, because it's flush with the back, so it should be the same as this. From that one to here as well, and I have this piece of 3/4-inch plywood, and I can move it around. It's not screwed yet. It's kind of jammed. That until I get it in the right position, so this is sitting in this dimension, it's sitting correctly straight up. And it should be correctly here. Now I just have to do left and right. I've screwed the back of it with pocket hole, Craig Jig pocket hole kit. This wire will get moved over here, so it's not in the way there. And then when I put my shiplap here, I'm also gonna glue this back side to the shiplap, so it's gonna be extra support. But mainly this is not gonna hold weight really, because all the weight is transferred down to the jack studs under the track actuator. What I've added here is a clamp, just to temporarily hold it until I move it left and right and adjust it, and then I can screw it. So I measured the distance there from the stud and then at the top, and I was hitting it here and adjusting it until it was the same distance from the stud. Of course, this helps if the stud is 90 degrees with the rest of the floor and everything. So I got these screws. They're normally for like metal, like roof to wood, but I like them because they have a bigger washers for the holes, for these holes right there. So I'm just gonna put them on there. There they are. And now this is solid. Hopefully it's straight up. I've done the same on the opposite side, in the opposite corner from the one I've done over there. So I have 2 of them done so far. So I put the 2 L brackets here, and under them I put a spacer with wood spacer, so it pushes them up against the bed frame. So that's how they're gonna be sitting. Now I came here for the back with a marker, and I'm gonna mark where I need to drill a hole for the bolt. 2 holes. Okay, same thing over here. I have drilled 2 holes in this L bracket and put these grade 8 bolts. I need to add a washer, lock washer, and nut there. So I have these Tex wood to metal self-drilling screws laying around from other projects, so I'm gonna use those and screw them in here, so they go into the frame to hold onto it. This is how it looks like. I should have a really get it recessed so it's flush. I might do that later. So based on my calculations, the bed frame and the ceiling that's gonna go under the bed and the mattress and everything is gonna be about 200 pounds. And each of the 4 track actuators is rated for 150 pounds. So they can totally raise together 600 pounds, and the bed will be about 200 pounds. So that's way under the allowed limit. So here's the problem I had. I noticed when it's going up or when it's coming down, one side is slower or faster than the other because I didn't put all the track actuators symmetrically in the 4 corners. So that side over there, it gets more support by the track actuator than this one single one here. So it ends up getting tilted. And if I have it screwed into here, it is basically like binding. So I need to make it more free floating. And I'm gonna try to do that by I bent the L brackets, and then they're gonna be pretty much free floating like this. So it will allow the movement, so one side can be a little lower than the other until it goes at the very top or the very bottom, then it levels out. So I'm gonna do that to all of them and then see how that works, if it's binding or not. The way I did it is I cut a notch with an angle grinder and a cutoff wheel to make it thinner, and then I just put in a vise, and with a hammer I bent it. I don't have a large metal bending brake to just bend them like this, so I had to cut into it. So what I'm gonna do is I'm gonna run a bit of weld there on the inside. Okay, you see how it's sitting now? It's not screwed at all. The bracket is just like a hook. And I have that on every one of them. So that will allow one side can be lower until it levels out at the top or the bottom. So it can be lower while it's going up or down. There it is. So this side is lower, but it's fine. It's not binding at all now. It's giving it a little bit of movement. Giving it some free movement. There we go. I reinforced this board by adding one in the back, and I glued it with wood glue, and then I have screws here going all the way through, and then these yellow screws go all the way through, and then I have I'm gonna add 2 more over here. done the same thing here, so that's gonna be solid. Most of the weight, of course, is at the bottom, which I have jack studs there, but I wanted to make this a little more strong, not just having these pocket hole screws. I had to cut the top that was curving of the bracket that I put, this L bracket here. I had to cut the top that was going inwards because that's gonna be hitting the framing. I mean, the shiplap. And you can also see how I have a flat washer, lock washer, and a nut, and you can even put some Loctite there. This electrical box is gonna be the switch for the bed lift. We have strategically placed it up high so kids cannot reach it easily, but also so we can access the switch both when the bed is up and when the bed is down. So that when the bed is up, it'll be above it, so we have access to it, and when the bed is down, it will be below it. And I put a 3-wire cable going into the switch because I bought this single pole, double throw, 3-pin switch, and I'm going to put that switch there. I also purchased a cover plate for this outlet, for this electrical box that has no holes in it, and I gotta drill a 3/4 inch hole here in the center so I can put the switch there. Okay, there we go. It's clipped on. So actually I think you gotta drill to 7/8, not 3/4. The switch came with 3 different wires, different colors, because I don't have these little connectors. These are smaller than a regular 1/4 inch. I don't have this small size. Otherwise I would have put the connectors here, which is what I might do. But for now I'm gonna just do a Wago fasteners. I got these Wago connectors, so I'm gonna use that. And then I'm gonna connect black to red. These Wago connectors are awesome. Red I'm connecting to black. Black I'm gonna connect to white. At this point, I mean, I'm just choosing the colors. You can really do it. There we go. Now I'm taking my switch. I'm gonna put 2 at the top, and I'm going to connect the red wire, which is the black for the long cable. I'm gonna connect that to the here at the bottom. Okay. And then I'm going to connect the black/white wire to the top one. And then I'm going to connect yellow-green to the middle one. Come in and close this. I'm taking my electrical tape here and I'm going to tape all these 3 wires to the switch to make sure they don't slide out from vibrations. Then I can come in here and tuck all these wires in. Got my screws for this cover plate. When it's on the 0 on the center, it's not gonna move. When it's down, it's gonna lower the bed. When it's up, it's gonna raise the bed to the top. That's nice and pretty. Let's look at the wiring diagram that I drew up. You're gonna need several components to make this bed lift work. There is a single pole double throw switch. It's a 3-wire switch. It has an on, off, on position, like on, off, on. Then you're gonna need a forward reverse relay module. That's the model number there. And there's of course your power source, which it's coming through from the battery. Let's say it's coming through the fuse box, then going to the relay, and then the 4-track actuators. You could technically skip the relay module and just get a double pole double throw switch, but that means all the current would have to go through the switch. That means that since each track actuator can pull up to 8 amps, that means that's 32 amps that potentially could go through the switch. So your switch then would have to be rated for at least 32 amps. And those are harder to find and more expensive. That's why I chose to use a relay, and then the switch just controls the relay. So all the high current is going through the relay and only a little bit of current is going through the switch. So then you can use any single pole, double throw, 3-wire switch for that. Now, the wires coming, I consider when I look at the switch I have, on the front of it has 2 lines, then a circle, then a line. So I consider 2 lines to be the up position, so the bed is raised, and then the 1 line is in the down position, the bed is down. So that means that I'm wiring the wire that's behind the up position. That wire goes to the top left of the relay. Now, first I want to say that this relay is, you'll see that it has 2 rows of screws and nuts. The one row has all the nuts the same size. The other one has the middle one large and the one on the outside small. So I position it that way so the small ones are on the top side. So coming from the switch, the wire behind the up position, basically, the 2 lines, on that goes to the top left of the relay. The middle one, which is off position, goes to the middle top of the relay. And then the bottom one, with the 1 line in the front, that wire goes to the top right. Then, coming from the fuse box, first I put 30 amp fuse there because I know it's not going to ever hit 32 amps because it will only hit 32 amps if the total weight of the bed and the frame and everything is like 600 pounds, and it's not going to be, it's going to be about 200 pounds. Each track actuator can handle 150 pounds, so total 600 pounds. So 30 amps is plenty. The wire coming from the fuse panel to the relay, the wires need to be rated for whatever the fuse rating is, like 30 amps. So I put two 12 gauge wires onto each positive and negative. Instead of doing one thicker wire, I did 2 12 gauge wires. That should satisfy the amperage rating. I did it because that's the wires I had, and it's easier to mount them on these tiny little screws. I put O-rings there. So the positive from the fuse box goes to the top middle, and then the negative goes to the bottom middle of the relay. When the relay is positioned in this position, you're looking from the top down. Then we have the 4 track actuators. The track actuators I got, they have a brown and a blue wire. So in this situation, the brown wire goes to the bottom left screw, and the blue wire goes to the bottom right for all of them. If by any chance when you try to raise the bed, it's actually track actuators are going down, all you need to do is reverse the red and these 2 wires, red and blue. So then the blue would go on the left and the brown would go on the right, bottom right. But if you buy the exact same relays that I got, and relay and track actuators, then would be the wiring. It's very simple. And this wiring and this design can be used for any situation when you have DC motors, 1 or more motors, where you want to reverse them, forward, reverse. Just for example, another use can be you have a solar panel slide out on the roof, and you want to slide out the solar panels because you have 2 rows, for example. Or you have a TV that is going to be raised up and down from a kitchen counter or a table or something like that. You can use this wiring diagram. Probably for the TV, you can skip the relay and use a double pole, double throw switch because the one motor wouldn't draw a lot of amps like these track actuators. But anyway, I'll have a separate video if I do that in our bus. Okay, I think that's it. One thing I want to mention, the wires going, if you're extending the track actuator wires, you just need to make sure that they are rated for 8 amps. The wire is rated for 8 amps. I put 12 gauge wire when I extended mine. I extended 2 of them. because that's the wire I had, but that's overkill because the wires coming out of the track actuators are not 12 gauge, they're thinner. Anyway, that's it. I think that's it. Let me know if you have any questions. Here is the relay and all the wiring I've done that I described in my wiring diagram. And now it's time to put the shiplap on the walls in our bedroom. So I have to work around the track actuators here. I want to try to minimize the visibility of the track actuators. You know, I'm trying to hide them in the walls. So first thing I've done, this bottom shiplap board, I routed it out because these pieces are sticking out on the track actuators. So I had to route that out, and then now when I put it in like this, it's gonna be nice and flush. So what I have here is just a piece of the shiplap that I cut off. I'm just using it as a spacer, basically as a guide to tell me where I need to stop with the construction adhesive. So I just draw a line where the studs are. I got the Gorilla Max Strength Clear construction adhesive, and I'm just putting some on the studs to really hold well in that area. Now I can come with my shiplap. Gotta make sure I don't hit any wires in the back. The bread nails are 1 inch long. Now I'm working on the next section up, and I have to cut them up into pieces, into basically 3 pieces, because the track actuator is going up and down, so I can't have them all through. It'll hit the track actuator, will hit the board. So the way I'm doing it is I'm going to be putting the track actuator almost touching this side of the bracket. It needs to end there, so to let the mechanism slide up and down. So that's what I'm doing. There's going to be a gap over here. Here's how it looks now. The problem I had is with the bracket for the track actuator would snag occasionally on these wires and pull the wires down. So I got these cable ties that have a screw hole, and I tied and screwed them, tied the cables and screwed this into the back side of the wall. And now it's got plenty of clearance, and it won't it won't snag on. One thing I want to point out when designing your system here for the bed lift is to make sure you take into account the thickness of your wall, and also any mounting hardware like bolts. You see over here I have it distance enough so it's not touching the bolts that are the bolt head that is in the back. Here's the progress. I'm gonna have some storage and shelves there, so I'm leaving those openings. This is how it looks like when I finish that wall. I still have to figure out a way to hide those wires, or have something on the front that will cover it as it goes up and down, like a fabric or something to cover the front or cover the back. But I think I'm gonna make a separate video for that. All right, let's test it out. I have the switch over here. Now notice when it reaches the top, it'll shut off automatically. Even though the switch is in the up position, it will shut off because the track actuators have built-in switches in them when they reach the end. And then, I can put it back into the off.